Introducing Thermo Calc 2020b, which includes a new kinetic model in the Process Metallurgy Module, the addition of several new thermophysical properties in 3 databases, the ability to calculate yield strength in the Precipitation Module TC-PRISMA, and much more. A kinetic model has been added to the Process Metallurgy Module, which allows users to simulate kinetics during the steelmaking process. The model is known as the Effective Equilibrium Reaction Zone Model, or EERZ. It assumes that local equilibrium at the liquid steel slag interface is reached, but that the kinetics of the reaction is limited. The addition of this model means that users can now model the entire steelmaking process from scrap to fully refined steel using the Process Metallurgy Module. You can read about the module and its implementation into Thermo Calc in 2 papers available on our website. The release also includes many resources to help you get started simulating kinetics in the Process Metallurgy Module, including 3 new examples that are packaged with the software. 2 of these examples have in-depth write-ups discussing the new model, and one of the examples also has a video, which you can watch by clicking the link in the upper right-hand corner of the screen. You can access all of the new resources about the Process Metallurgy Module on our website. Several new thermophysical properties have been added to 3 databases in the 2020b release, as shown on the screen. The thermophysical properties are available in Thermo Calc as plot variables, parameters, and more. Starting with the 2020a release, we began adding thermophysical properties to some of our thermodynamic databases, which previously only contained Gibbs energy and volume data. Thermophysical properties are essential for simulating the mass and heat transfer in material manufacturing processes, such as casting and 3D printing, but they are usually not available in composition-specific form. By extending our thermodynamic databases to include additional properties data, users will now be able to easily calculate thermal conductivity, surface tension, viscosity, and more in variation with multi-component compositions. Additional thermophysical properties are currently being added to these and other databases. New additions will be announced every release, so keep an eye on your databases to see when they receive new thermophysical properties. New examples are available showing viscosity and surface tension in Thermo Calc, as shown on the screen. In addition to the thermophysical properties, these 3 databases have other upgrades for the 2020b release. TCAL7, the Thermodynamic and Properties database for aluminum, adds 3 new elements, bringing it to a 39-element framework. The database also adds 7 new binary and 10 new ternary systems. The Metal Oxide Solutions database, TCOX10, adds 3 new elements, bringing it to a 28-element framework. 67 new phases have been added to the database, as well as 28 new binary, 41 new ternary, and 11 new quaternary systems. The nickel-based superalloys database, TCNI10, adds 1 partially assessed ternary system. Several binary and ternary systems have also been updated. The database also receives significant improvement of solvus temperatures for many alloys. 6 databases have also been updated for the 2020b release. You can read about all of the new and updated databases on the release page on our website. The yield strength model in the Property Model Calculator has received several improvements to make it more accurate. It has also been added to the Precipitation Module TC-PRISMA to allow users to use the results of a precipitation simulation as input for a yield strength model. Grain boundary strengthening has been assessed for all elements and has been optimized for pure elements. Additionally, the Hall-Petch parameter, which is used to estimate the grain size hardening, has been improved. The parameters in the Solid Solution Strengthening Model by Walbrell et al., as shown on the screen, have been reoptimized. As a result of these improvements, the yield strength model now shows a better fit to experimental data when compared to previous versions of the software. The model also now allows users to set up more than 1 precipitation phase when calculating precipitation strengthening. The yield strength model has also been added to the Precipitation Module TC-PRISMA as a plot quantity, Precipitation simulations are set up in the Precipitation Module as usual, then users simply select yield strength as a plot quantity to access the model directly from within TC-PRISMA. A configuration panel appears which is the same as the panel in the Property Model Calculator. Here you can select the Precipitation Strengthening model, set the parameters, and so on. The program completes the precipitation simulation, then automatically uses those results, such as matrix composition and precipitate amount and sizes, as the input for a yield strength model. Results are visualized as a function of time directly from the Precipitation Module. This is the first mechanical property to be added to the Precipitation Module TC-PRISMA. Example P1, Precipitation Aluminum-3 Scandium, has been updated to demonstrate this new feature. The example includes an accompanying video that shows how to use the new model. You can watch this video by clicking the link in the upper right corner of the screen. The Poly module used in console mode and APIs has a new command which makes it easy to suspend a component. Make component suspended. This command is useful when an element has a very low amount because you can now ignore it in the calculation instead of reading the entire system from the database, which can save a lot of time. Additionally, calculations can fail when using small amounts as conditions, but they will not fail when the components are suspended. This new command is especially useful when working in an API with many calculations. Users could already suspend components using the change status command, but this new command is much easier to work with. Benefits of the new command are listed on the screen. For users who work in the PARROT module, Guess 6 is now supported in PARROT. Guess 6 is the part of the calculation engine known as the Gibbs Energy System Module, or Guess. The module was completely rewritten from the older version, Guess 5, in Thermo Calc 2019b, but at that time it did not work in the PARROT module. Users who work in PARROT can now use Guess 6 with all of the functionality they are used to in Guess 5. To learn about all of the new features, updates, and databases discussed in this video, as well as other details of the Thermo Calc 2020b release, visit our website at www.thermocalc.com/release.